Tech in 5.
In an age where everything is online, how safe are you really? Database security in this context refers to the practices that protect the database from unauthorized access and manipulation, especially through SQL injection attacks. These attacks occur when an attacker inputs malicious SQL code, which could lead to unauthorized data access, data manipulation, or even destruction. By understanding and addressing SQL injection risks, we lay the groundwork for a secure and resilient digital environment. Preventing SQL injection is crucial for three main reasons. It ensures data protection by keeping sensitive information secure, maintains system integrity by preventing wider breaches, and ensures regulatory compliance by meeting essential data security standards. Each aspect is vital for a secure, trustworthy database environment. In Java, one of the most effective defenses against SQL injection is the use of prepared statements. They're precompiled by the database with placeholders for input. This means when we insert user data, it's treated purely as data, not executable code. It's a simple yet effectively neutralizing injection threats. JDBC's prepared statement is key in Java for preventing SQL injection. ORM frameworks like Hibernate or JPA take this a step further. They abstract the SQL layer, automatically handling data as parameters, which not only streamlines development but also secures it against SQL injection, almost like having an automatic guard against these threats. Let's put theory into practice with a real-world example. Imagine we're fetching user details based on a user ID. With a prepared statement, we'd set up our SQL query with a placeholder for the user ID. Then, we safely insert the user-provided ID as a parameter. The beauty of this approach: no matter what's inputted, our query's structure remains unchanged, immune to injection. It's this practical application of prepared statements that showcases their value in safeguarding our Java applications against SQL injection. In C#, parameterized queries are our shield against SQL injection. This diagram illustrates the process. We start with a SQL command, specifying placeholders for user inputs, like at user ID for a user's ID. These placeholders ensure that user inputs are never directly added into the query string, but are instead passed as parameters, preserving the query structure and preventing malicious injections. The flow from user input to the parameterized query highlights this crucial separation, making our applications more secure. Let's see parameterized queries in action with this C# example. We're querying user data by ID, a common operation that could be vulnerable to SQL injection if not handled properly. By using a SQL command with a parameterized query, we assign user input to @user_ID, ensuring it's safely incorporated as data. This approach keeps our SQL structure intact and our application secure, demonstrating the power of parameterized queries in protecting against injection attacks. In our final overview of database security best practices, let's highlight some fundamental best practices. Top of the list is using prepared statements and parameterized queries, essential in blocking SQL injection for both Java and C#. Equally important is validating user inputs to eliminate vulnerabilities, ensuring users and applications have only the necessary database privileges, and regularly auditing our SQL practices and database setups for potential risks. Incorporating ORM tools can further shield our applications from injection attacks. Additionally, ensuring safe SQL execution by avoiding dynamic SQL when possible and keeping database drivers and libraries up to date can further shield our applications from injection attacks. In conclusion, safeguarding our web applications isn't just about employing specific techniques. It's about embracing a comprehensive security mindset. This includes a blend of solid coding practices and a commitment to continuous learning. Staying ahead in database security means outsmarting ever-changing threats.
Stay tuned for more videos on Tech in 5.